How's it going? So today actually we're going to be going through two equations. The first one is going to be subarray sum equals to k. The second one is going to be subarray sum divisible by k. We're not going to change a lot of code. I feel like these two equations are similar. Anyway, so what does this question want? So we're told that, actually, let me zoom in for you guys. Yeah. So we're told that we're given an array of integer nums and integer k. We need to return the total number of subarrays whose sum equals to k, right? And we can think of a subarray as a continuous non-empty sequence of elements within an array, right? So they are intact. So if we look at the example that we are given here, we can see that they have triple ones, and the k is 1, the k is 2. So we can see that they took this 1 and 1, which is 2, right? So they took this 1 and this 1, which is another 2. Then the results here, that's why it's 2. Okay, so let's look at the second example. So here we're given k. Here we're given k, which is 3. So we can see that if you take 1 plus 2, you're gonna get 3, and if you take this 3, you're gonna get 3. So hence here the results, they have 2. Okay, so now I would like us to create our own example, and let's walk through how we can actually solve this, right? So let's say we have this array, 1 2 3 4 5 6, right? And let's say k in this case equals to 6, right? So one way we can go about this is that we can actually have a for loop starting at I up to n, right? So we can create another for loop starting at j all the way to I plus 1 and up to n, right? And we can create a sum here so that we can keep track. So we can say nums I. So we can think of like we're storing this element here. Okay, then what we do is that we ask ourselves if the current sum equals to k. If it is, then we increment our count because the question says they want the count, right? So we can say plus equals to plus 1. So initially count will be 0. Okay, then what we do is that we take sum, we overwrite it, and we say equals to sum plus j, what is it, num plus j, right? This is one way we can go about it. It's a naive brute force way we can solve this. So essentially what I'm doing here is that I'm going through each element, and then I am from j, I'm starting here. You can think I'm starting at this element and going through and taking all of the sum, and all the time as I'm adding, I'm checking if what I've added equals to k. If it is, then I increment this, right? However, as you can see, this solution essentially is going to be O of n squared. And looking at the constraint, it's clear, remove the constraint, but we're supposed to have a solution that is a temporal complexity of O of n. So that's where the complexity is going to be now. So before we get into the solution, I just want you to give you some sort of like an intuition. So let's say we have A, B, C, D, E, F, right? So let's assume that the sum from A to F is Y, okay? And let's assume that the sum from A to C is X. Is it okay for us to say, if we take Y and we subtract it by X, we're gonna get the sum for these numbers here, right? We already know that we have k. K is always given to us. If it happens that these numbers here, they sum up to k, can we increment our count by 1? Yes, we can. Because it means that the subarray here is equals to k. So this is plus 1, right? So that is the intuition behind this solution that we're going to come up with. It's called the prefix. So going back to the real world example, so let's say we have 1, 2, 3, 4, 5, and 6, right? So we know that we have k, which is equals to 6, okay? We want to compute the current sum, which is we're going to call it x. So we are looking for y, we don't know y, right? So we start here at this first element, right? We have sum, which is equals to 0. So x is going to be 1, which is, as we loop through, sum is going to be 1 at the current index. Then we go to the next index, which is 2. We take 1 plus 2. We add them together, we're going to get 3, right? And as we keep the sum, we need to keep track of them. So we use a hash, right? Because remember that we need to somehow, if we subtract k, if we take x and we subtract k, we're going to get x. We're going to get y. So we can increment the count, right? The same thing that we did here. Don't forget that what we did here, going back, we said that if we take y, we subtract it by x, we're going to get k, right? So similarly, if we take x, right, and we add it with k, we get y, right? We can reverse engineer this. So this is what I'm doing here, is that I am saying that we already have k, so we are looking for y, right? So we have x, which we're continuously adding, right? And we're storing it inside here. So we stored 1, we went to the second element, which is 2, and the sum became 3, okay? So as we continue, we need to ask ourselves, if does the sum subtract k, right? It's in the hash map. If it is in the hash map, we increment the count by 1, okay? So we go to the third element, we ask ourselves, 3 plus 3 is equals to 6, right? 6 minus 6, this is 0, so we don't have it in the hash. So we store the sum, which is 6. We go to 4, 4 plus 6 is equals to 10, right? We ask ourselves, 10 minus 6 is equals to 4. 4 is not in the hash map, we store 10. We go again, 10 plus 5 is 15, right? 15 minus 6 is 9, so we don't have 9 in the hash map, we store 15, right, as a key. We continue, we get to 6. 6 plus 15, which is 21. 21 minus 6 is 15, and we have 15 here. So we increment our count. Okay, so our total count is going to be 1. And I forgot to write a code to say, if it happens that the current element that we add, so if nums I equals to k, we increment the count plus 1, because the current element is the same with k, so we're going to add it, right? So the count is going to be 2. And that's the final count, that's the correct value, okay? So in case you're still confused, I want you to understand that you can think of like, we know the sum from here to here, right? The sum from here to here is 15, right? And we call this element is x, right? And we have k here. So if we add 6 here, right? We add 6 here, which is going to be x. If we subtract this x by k, we can get 15, this element here, which is here. So this is why we know that this element here, which is y, right? So that's why we're able to increment count by 1. Okay, I don't know if that makes sense, but that's like that's how I understand it, and this is how I think it's kind of like works. But I know maybe it's confusing. I think the best thing we can do is that let's go to the code and see. You will understand it. I think maybe if I code it up. So what we're gonna do is that we're gonna take n equals to the length of, I think we're given nums. Then we're gonna get the hash map, which is gonna say just to avoid edge cases, I'm just gonna use a dictionary, and I'm gonna say lambda equals to 0. Okay, then we're gonna have a count, keep the count of the subarray. Then I'm gonna have sum, which is I'm gonna make it 0. So what I'm gonna do is that I'm gonna iterate through each element for I in range of n. Then what we do is that we take the sum, we say plus equals to nums I, right? We check if the sum is equals to k. If it is, then we increment the count plus 1. Okay. Then we said that if we take the sum and we subtract it by k, right? If this thing here is already in the hash map, right? What we want to do is that we want to increment the count. I think you just have to think of it from the yx as example that I just gave. So you just want to take the hash map and we're gonna say sum minus k. Okay, then I'm gonna continue to store the hash map. I think I'm using capital letter M. So I'm gonna store the sum inside here. I'm gonna say plus equals to 1. We don't care about the value that much. When I'm done, I'm just gonna return the count of this. Okay, it's this small letter. Yeah. So I'm gonna run this. I think I made a mistake right here, right? So it's capital letter S. I'm gonna submit. And it works. So let's go to the second question, which is we're not going to change a lot of code. This is the second question that I was telling you guys about. So as you can see that literally we changed, I think, only the symbols. That's one thing that we did. So it's literally the same, and even the explanation is the same. It's just that this question says subarray sums divisible by k instead of equals to k. So this one, it has to be divisible by k. So what we did was that we take the sum and we check if it's divisible by k. So if this is equals to 0, we increment the count. And if we want to store this in the hash map, we increment the count. Else, we just store that element that we just store the sum divisible by k in the hash map, and when we're done, we return the count. So it's literally the same with what we did. It's just that here we just need to make sure that we get the subarray count that is divisible by k. Okay. Yeah, I hope you guys got this. Yeah, if like this was confusing, let me know. Maybe I can improve in terms of explanation. But I really appreciate you watching. Thanks.